Hello students and welcome to the world of free education. This is Edupedia World and you are watching operations management videos. Continuing with the facility location, today we'll see another important and easy method of determining a suitable facility location, and that is the center of gravity method. Well, the center of gravity method is also called as the grid or the centroid method. Why is it called as the grid method? The reason is that this method, like the previous two methods, that is the load distance and the simple median method, also uses the grid position. Okay, and this is also based on the distance like that of the load distance and the simple median method. Here once again we make use of the graph or the grid where we place the map of the region from where we have to select the location. Okay, it takes into account the existing locations of plants, the market, the supply center, and so on. Further, it takes into account the volume of goods which are to be moved from these centers and the transportation distance or the cost. So basically this is based on the principle of cost consideration. As we know that the cost is a function of the distance moved or the number of goods or the volume of goods which are to be moved from one location to the other. Now this method once again can be used to assess the managers in balancing cost and the service objectives. This will give you the location which will have the minimal cost. In addition, the other service objectives could be combined and a decision about the location of the new facility could be taken with the help of the values which we get through this. Alright, so now let's understand what basically is the center of gravity. Well, don't confuse it with the term center of gravity in physics, although you can draw some parallel. Here center of gravity is defined to be the location that minimizes the weighted distance between the warehouse and its supply and distribution points. Okay, where the distance is weighted by the number of tons of goods supplied or consumed. Okay, that is the volume of goods which are moved between different centers. Alright, so moving ahead, the center of gravity method finds the location of single distribution center serving several destinations. Now if we look at all the three methods based on the grid positions, the load distance method, we have few prospective location in addition to the existing locations. That is, we have a few candidates which are limited, 1, 2 or 3, and out of these we select the one which has the minimum distance from all the existing locations. Okay, whereas in the simple median method the entire region is actually a candidate, and from out of these region we select just one single distribution center or one single location. Okay, same is the case with the center of gravity method, although the method differs, the method of selection differs, but the entire region is a candidate. That is, we can have a new location placed anywhere in the region. Okay, further this method assumes that the distribution cost is a function of the volumes shipped and the rectilinear distances in the x and y coordinates, and we have already seen this point. Rectilinear distance in the sense that which allows movement only in the north-south or east-west direction. Yeah, exactly, the movement in the horizontal and vertical direction on a map. Alright, the distance in each of the x and y coordinates are averaged using the volumes as weights, and the resultant coordinates then constitute the center of gravity for that grid, and that is selected as the new location. Alright, so now let's look at the steps in determining the most suitable location using the center of gravity method. As usual, the first step in this procedure is to place the locations on a coordinate system like the previous two methods. The origin of the coordinate system and the scale used are arbitrary, just as long as the relative distances are correctly represented. This can easily be done by placing a grid over an ordinary map of the region. Thereafter, we find the relative grid position of all the existing locations, and also we find the load at each of these locations. So once the relative position, the grid position of each location is found, and also the loads at these positions, then the center of gravity is determined by the formula given here. We will have 2 points. One is the x coordinate, we call it as xc, and another is the y coordinate, yc. Xc is the ratio of the sum of the product of the weights and the x coordinates divided by the sum of the weights, okay, or the volumes of goods moved. Similarly, y coordinate is the ratio between the sum of the product of vi and yi divided by the sum of vi. Okay, we can see what these points are. The xc and yc are the x and y coordinates of the center of gravity, that is a new location. Vi is the volume of goods transported to or from each of the ith destinations. Xi and y are the distance traveled by the goods in x and y directions respectively. Once we have determined the xc and yc coordinates, this would constitute the starting point for a new site. Okay, why starting point? Because the location in that vicinity may be evaluated and changes suggested, and perhaps some recalculations could be done before the final choice is made. As I said previously, this provides the guidelines to the manager regarding the decision about locating the new plant. This will give you the most suitable location numerically, but we may have other considerations. Like, for example, this doesn't take into account the terrain, the availability of roads, and other factors. Okay, so including those factors, we can come to a conclusion and decide about a new location in the periphery, in and around the point which we have got using this method, that is the xc and yc coordinate. Alright, so this was the step we have. Let's understand this by using a numerical example as usual. Let's say we have a map of a region. Let's have this is the map of a region, and let's place it on a graph, something like this. Okay, we have the x and the y coordinate, that is the grid. And let's say we have 4 existing locations available. The first one is at say 10, 2, say 10, 2. The second one is at say 10, 10. Let me call this as A, this as B. The third one is say as 8, 6. I think it will go a little above here, 8, 6. Let me call this as C. And finally we have, let's say 12, 5, somewhere here. Okay, let me call this as D. This is at 12, 5. Alright, so we have got 4 positions. Let me write them here clearly. You have A, which is at 10, 2. You have B, which is at 10, 10. You have C, which is at 8, 6. And finally you have D, which is at 12, 5. And then we also need the loads at all of these locations. The loads, as we know, could be the amount of goods moving, or in case if it is a service industry, then it could be the number of people traveling or moving into or out of these centers. Okay, so let the weight at A be 6, could be 6,000 or 6 million or 6 tons. Okay, at B it could be 10. Let's say at C it is 8, and at D let's say it is 4. So we have the loads at all of these. Let me write that here. We have the load and we have the x and y coordinates here. Fine. So now coming to the center of gravity method, we know the formula is we need to find xc, which is the sum of let me call load as V, We need two positions. One is the value of x in the coordinate, another is the value of y in the coordinate. The x will be the sum of the product of the load and the x coordinate divided by the load, and the y coordinate will be sum of the product of the weight and the y coordinate divided by the sum of the weights. Now this is very similar to the finding the arithmetic mean. Okay, we take the where we assume the values here, the load as the weight or the frequency. Let me put this in a table. We have the locations, we have the x coordinate. We'll have to draw two separate tables for x and y. We will have the weights here, or let me give the name as v. We are using v, the variable. Alright, so we have four locations, A, B, C and D. We need to find the value, write the values of x here. It is 10, 10, 8 and 12, and the weights are 6, 10, 8 and 4. We will have to first find the product of x and the weight. So 10 into 6 is 60, 10 into 10 is 100, 8 into 8 is 64, and 12 into 4 is 48. Fine. Then I need to find the sum of this. When we sum this up, this will give me 272, right? 8 plus 4 is 12, 2, 1 carry on, 6 plus 1 7, plus 6 is 13, plus 4 is 17. Again 1 carry on, 1 plus 1 is 2. At the same time, we also need to find the sum of the weights, and here when we add, it's 16 plus 8, 24, plus 4, 28. The sum here is this. And when I put this value here in the formula, I'll have the value of xc as 272 divided by 28, and that will give me 9.7. Fine. So 9.7 is the value of your x, grid x, okay, xc. In the same manner, let's find the value for y. We have the locations, we have the y coordinates, we have the v values here, and we have the y multiplied by v here. So first we have location A, the y position of that is 2 and the weight is 6. Location B has 10 and the weight is also 10. Location C, it's 6 and 8, and finally location D, the y position is 5 and the weight there is 4. Okay, next let me find the product of these two. So it's 12 here, it's 100, it's 48, and finally 5 into 4 is 20. Coming to the sum of these, we will have the sum of weight unchanged, and the sum of y multiplied by v will be equal to 180. Yeah, 8 plus 2 is 10, 0, 1 carry on, you have 4 plus 1 5, plus 1 6, plus 2 8, and then 1, so 180. Coming to the calculation of yc, it will be 180 divided by 28, and that will give me 6.4. Alright, so my yc value here is 6.4. So now if you put that here, it's 9.7. okay, somewhere here, this is 10, so 9.7, very close to this, and then 6.4, we have our 6 here, so it's somewhere over here. Okay, so this is the location of our new plant, the most suitable location, or you can say this is the center of gravity of this map. We can search for the most suitable location around this place, taking into consideration the other factors, and that will constitute as the new location. Alright, hope you have understood this, and I'm sure this is simple as the previous methods. And so now you can work out some problems yourself. Let me give you a few problems. Alright, so here we have the first problem. You have a table given below with 8 market locations to which a manufacturer of wooden windows expect to ship its products. The shipment volumes and the x and y coordinates of the locations are given. You have to use the center of gravity method and find the xc and yc coordinates and suggest a possible warehouse location. So very simple question, straightforward. You need to work this out You have all the required data given. You need to find the XC and YC coordinate and suggest a suitable warehouse location. Alright, we have another question, and this question is same as that of the one which we solved for the load distance method. We have modified the question slightly to suit here, and we can use this for comparison to see how it works and what is the most suitable location if we work using the center of gravity method. So here the question goes: the new healthcare facility is targeted to serve 7 census tracts in a city. The table given below shows the coordinates for the center of each census tract along with the projected populations measured in thousands. Customers will travel from the 7 census tract centers to the new facility when they need healthcare. If we use the population as the load and use the rectilinear distance, where do you think we should locate our new facility? Okay, so of course you can make use of the center of gravity method because we have the grid position here and we have the population. So now pause me for a while. As usual, solve both these questions yourself and then you can check your answer when we solve it together after a while. Alright, so here is our first question, the solution to the first question. We have 8 market area mentioned from A to H. We have the X coordinates and the Y coordinates which are given in kilometers. These are the relative values, and then finally we have the volume of goods which are to be moved from these locations. Okay, we need to find the center of gravity. First we need to find the product of the X and X coordinate and the volume. So here we will have X multiplied by V, and then we will be needing Y multiplied by V. Okay, straightforward and simple. We'll take the product of the values under the column Xi and Vi. Okay, so that will give me the value 20, and the same manner I can take the product of the values Yi and Vi here. This will give me the value for Y into V. I can drag this down to all the 8 market area. Yeah, so now I have the values for all the 8, and then I simply need to find the total. I need to find the sum. I need to find the sum of volumes. And also I need to find the sum of the product of X into V and Y into V. So here I have the values of the sums. Next I need to find the average. Yeah, same like that of the arithmetic mean. So I need to find the average of the sum of the product of X into V divided by the volume, and here we have the value is 9.87. In the same way I'll have to find the average here for Y, and that will be 5.27. So now the most suitable point, okay, in the grid is 9.87 comma 5.27. Alright, so that's the most suitable location for us in the first question, and here I have the summary of the answers: 9.87 comma 5.27. These are my XC and YC values. Okay, coming to the second question, here we have it. Again we can use Excel, and of course Excel has made our life easier in solving all the problems almost in every exercise. We are using Excel with ease. So here once again I'll be using the product of XV and YV in both these columns. Let me do that. X multiplied by V and Y multiplied by V. Okay, so X into V will be equal to the value here multiplied by the population. The same way Y into V will be the value here multiplied by the value of the population here. So we have X into V and Y into V. Let me drag this down to all these 7 region. Fine, we have the values, and then I need to find the sum total of all of these. Total, we need to find the total population also. So now we have the total value of all the 3. Coming to the average, this will be 6.67, that is XC is 6.67 and YC will be equal to 3.02. So my most suitable location for this problem is 6.67 and 3.02. This is my XC and this is my YC values. Okay, now the managers can look at the the region, the terrain, and work out themselves and see which location would be the most suitable. Coming to the summary of the solution, here we have the most suitable location mentioned here is 6.67 and 3.02. Now we compare this with the solution which we got under the load distance method for the same problem. We saw that the location was at 7, 2. Why was it so? Because we took only 2 points and there were just 2 points which were under consideration, and out of these 2, this is a better location. Okay, we did not consider the whole area, whereas the center of gravity considered the whole area and it found the most suitable location in terms of the mathematical center. Center of gravity will give you the mathematical center, whereas the simple median method will give you the positional center. Okay, because that works on the principle of the median and this works on the principle of arithmetic mean. Alright, so these two methods, the simple median method and the center of gravity method, considers the whole area, and out of the area they find the best and the most suitable location, most suitable point. Whereas the load distance method, you have some candidates, maybe 2, 3 or 4, and you compare those 3 or 4, and out of those you select the one which is the most suitable. Hope that is clear. Now further to consolidate your understanding and test your skills, you can work out all the various problems under the 3 which we have seen by various methods, by different methods. Alright, so that's all we have for this session. Keep watching our video, and if you like our video, you can share with your friends. Okay, and for more videos on various subjects, you can visit our website www.edupediaworld.com. Our only motto is virtual world free education. Thank you.